Hi, this video is for the IT 265 class in spring 2021. So I will be teaching American Necessity, and I teach in the IT or informatics program. And this is a quick intro video just to explain how the spring semester is working. Um, so we do, actually, I'm just going to bring the schedule over 1 second. Move down. And let's see, 265. Okay, here we are. So game architecture and design. So Fridays, 12:30 to 3:20. The semester does start up next week. So our first class will be the 22nd. So the way that the online classes have been working as of last semester with the pandemic and everything going remote is that I create the lecture videos. You watch them before class, and you do as I'm doing, and you start working on your project or doing the readings or research or whatever that week is about. And if you're stuck or you have questions, or you need technical, help in Unity, then you come into class time. So think of class as like structured lab time that's always there for you. But the lecture videos are online. They'll be on YouTube. They'll be organized on Canvas. The whole portal, the whole like main class is going to be up on the Canvas page, and you just move through it week by week. And there'll be links for each week that connect to YouTube videos. So you do the videos at your own pace over the week. Just it's all about self-regulation of your time. And make sure there's not enough work, but enough to actually get some learning points across, and you can leave the semester with a small defined skill set from the class. So, for example, this coming week, 18th, we have off, and classes start up on the 19th. And I'll want you to have watched some lecture videos before the 22nd. I'll send out an announcement as well. So hopefully with this video and with the announcement saying watch these series of videos first, then come to class if you have questions. Hopefully, the first week is always messy. So there's a lighter amount of work. So hopefully, if, there's a batch of students who come in to class on Friday and expect a lecture, they'll still have time to get caught up and do the lectures on Friday and get caught up with the rest of the class moving into the second week. So you have to get comfortable with this online format. This Friday at 12:30 to 3:30 is come in if you need help. You could also come in and sit there and just mute yourself and listen to the videos, or just work on your projects if you need that structured time as well. But what really happens, are the best way to make use of the time, is do the lecture videos throughout the week. If you have questions, now you have all this extra lab time to get help as you're working on your project. So we start up this Friday, January 22nd, and think of this as lab time that's open to you 3 hours a week. And we're also available, email, and I'm very quick on email. And if I need to meet up with you outside this class time, then that's quick to set up as well. So with that out of the way, let me say that the class is broken up into 3 monthly sections with deliverables at the end of those sections. And I have to play with the structure of the class. I might have some midpoints deliverables. But we ran this class last semester, and the main structure went well, but I'm going to adjust it for this semester because the main thing that happens when you do an intro to a game design class is that there's so much to cover, and students usually all their projects are so diverse that they get and so complicated that it's just so hard to baseline everybody, and it's so hard to get everyone help on their projects because they're just so scattered to the wind. So game development, which is just a subsection of software development, is very complicated. It takes a long time to get comfortable with. We have a series of classes here at NJIT that hit on many different aspects of game design. And this one is really, you need to understand the full life cycle of software design and development. So, since my focus is on educational games, I'm going to be talking about educational games. So there's many different genres and types of games and different platforms and different ways to interact with them. And all games aren't just based on the computer or in a digital domain. There's the idea of a game is a very abstract and wide-ranging idea. We will focus on the idea that a game is a piece of computer software that is really heavy with interaction and with multimedia. So the input to the user are the output from the computer, being a visual and audio nature, and the output from the user and the input back to the computer through some type of input device, whether it be keyboard, mouse, gamepad controller, hand controllers, touch screens, what have you. That's the interaction point. So usually the user is presented with information. They're aware that they're playing a game. They're taught some basics of how to interact with the game, and then they kind of go through some like tutorial or some level 1 to kind of learn all the major points of the game, and their information is given to them from the computer to the user. The user makes decisions, and the user expresses those decisions through their muscle activity on the input device, which we talk about as interaction. And that those interaction commands, those input commands to the computer change the back end. It changes the simulation of what's happening, and then those results are cast back to the user as audio-visual information, and that loop just continues and continues. So you can use video games for entertainment. You can use them for education. You can use them for productivity. So the core of this is that there's some type of back-end simulation, some virtual world being simulated. The user is usually represented as an avatar, some type of localized entity. And it's really this back and forth, this loop between the user and the computer that we make interesting changes and designs to make it more about an entertainment or an education piece. So you can think of games as, yes, we have to follow all the rules of software, which we're going to learn about software research, software design, software development, and all within the aspects of, well, this is an interactive multimedia piece of software that can be a mixture of education and entertainment. So while I've been a lecturer here, I've been pursuing my PhD, and my PhD is in educational gaming. In this case, I mostly focus on development on the Oculus Rift virtual reality headset, and what I'm teaching is computer science basics. And so I gamify it, we make it fun visually, as you can see on the screen, and we make the interactions in the world that you can move around as interesting as possible, because it's meant to engage a younger student into the world of computer science and make them interested. And usually these STEM fields, science, technology, engineering, mathematics, are usually drier. And so we use more interesting ways of using technology to interest the user or the learner to be more interested in the field. So we're using games with a purpose. We're trying to make young children more interested in computer science. So you can think of the person using the software. The terms that we use are user, player, learner. All right, so all software, there's no point to it unless it's solving some type of human problem. And so that's why we always have a human component with computers, and we call the human the user. They're using your piece of software. How do you wish to design and develop the software to solve the problems of the user? Now, the user is also called the player when the piece of software is a game. And so they're playing a game. And then if it's an educational game, we call them either a player or a learner. They're playing a game that's meant to help them learn something. So this whole class, we're going to be looking at the research, the design, and the development phase of gaming software as it can be used in a learning situation. So let me say that these videos I'm showing are the VR game that we called Seespresso, where you move around the space station and you interact with these stations for different tasks to see if you can solve the task correctly or not, if you understand what we're trying to tell you. Now, interestingly, games, I would almost consider games a subset of educational games, because you always have to make sure that the user or the player understands what the point of the game is. And if the game's too complex or too random, the player doesn't see any interesting patterns that they can play against and try to solve, and it becomes boring for them. So even the most entertaining game at its core has an educational or a learning component or substructure to it. And because games are in its essence ways for us to have fun, and for us to have fun, there's some type of like pattern recognition and forecasting, and that's how we learn about our environment. So all of this I talk about at depth throughout the semester. I'm just trying to give a nice overview. Now, the other issue with teaching a game design, or an intro to game design class, or an intro to software design class, or an intro to educational gaming class, basically, when we first approach software design, or in particular game design, we have this issue where the class's structure gets really wild because the students pick all these projects. They're brand new to software design. They're brand new to programming and game design, and there's a lot to learn. And so I've found, actually, with iterating on these type of design, software gaming design classes over the years, that we're going to focus on a cycle of prototyping. So that if you understand how to develop the point of the software, the problem space, the solution space, and then you know how to prototype to express your ideas out, at least that gives you a full suite of skills that you can always enhance, because then you have to move into programming. All this needs to be fully interactive. Then you need to move into, let's say, the graphics, the graphic design, or the level design, or more enhanced game system designs. So I found that if I'm trying to get this class refined down to a core set of skills, that at least anyone coming in with no experience or little experience in all these areas can understand what this broader field is about, can understand what all the many application areas of this field is about, and can continue growing any of these wide range of skill sets independently or with others in classes here at NJT, or by yourself at home on YouTube or some type of other learning channel, that you can continue growing all these many facets of game design. And so that's really what I've refined these classes down to be. And so I'm not going to be I'm going to explain all the code in my projects. And I found that it gets too complicated too quickly for the average beginner. And then when you try to have to do it yourself, it's even opening up a bigger can of worms, because there's just so many areas to programming to just shove into one class. And programming takes time and experience. And so you still will have to do light programming in the class, but ultimately you're going to make a prototype that will rely more on using what I think will be the animation system in Unity to express your ideas, express changes of a set of objects over time to show what the full interactions might be like. And then you can, in future classes, so if you go into like game production where it's more like let's create a fully interactive game, you can push your ideas even more and actually replace the non-interactive animations with interactive coded elements. And also, if you choose to work with teams, this whole skill set you'll learn in this class will be super helpful because you'll be able to express your ideas, diagram your ideas, write about your ideas, and then actually create prototypes. While they might not be fully interactive, it gives a huge understanding to the programmers that you work with, and they'll be able to execute on those ideas a lot better. So I just want to, I'll show you the weekly schedule quickly. This is going to change a little bit more because each semester we refine down on these class ideas better, but you can see the gist of it. We have 3 major projects or sprints. Each one is about a month long, and we're going to break it down into a full software development lifecycle, where it's the first project is UX research. UX is user experience. Again, all these terms and all these ideas and all these processes I'm going to explain at depth during this class. But part 1, research. What is the problem that your software or your game is looking to solve? Part 2, design. What are the possible solutions that your game or your software can solve for this problem space of the user, of the player? And part 3, how do you prototype this design idea? How do you build it enough where you've proven that the idea can actually function well as a piece of software where you're ready to code up the whole thing? And these stages cycle a lot. So you research something, you design for it, and you prototype it, and you keep cycling. There's just more and more features you look at. You don't just design something. You don't just build something. To build something, you must first design what it is. To design what it is, you must first understand what you're trying to solve. So software is used to solve problems in our human world, in our human society, in the physical world. And so you have to research what the competitors are doing, how you wish to approach it, what you're going to do different, what type of game's already in your space, and how do you wish to improve on that game in that space, in that platform. So what this all will look like is we're going to be in Unity quite a bit. There's going to be a lot of readings. You're going to do writing, but each stage, each of these 3 sprints, each of these 3 stages of the class, we're going to be moving more and more into Unity. So in this case, this was my bubble sort trainer. This was the part of the educational game that I did for my PhD in virtual reality. I just acclimated it for a desktop version to be played over the web. And so I'm in Unity, and if I click play, and we're going to learn all the basics of Unity in this class as well. We see that we have a title screen, our start page, or splash screen, the game title, the subtitle of what it is, and we have 3 areas that we can go to. And this is the prototype that you will build out over the course of the semester. So for part 1, you're going to build out the intro. And so you're going to learn about user interfaces and light coding and Unity scenes and 3D objects and all this kind of a basic intro to the game engine. But for the research phase, after you research the problem and you figured out like what type of educational game you're going to make with very little bit of learning objectives and then some game objectives, you're going to be able to build the intro. You're going to explain your research phase. So here you learn about the user face elements like text, images, colors, buttons. And so this is just explaining my research phase, which you will go through and you'll build your own research phase. I got my overview, my proposed solution that I might be moving towards. I got my competing software review, my suggested improvements from the competing software review, my stakeholders and users, basically who am I thinking about as I'm designing this software, this persona, this kind of abstracted out person who I'm going to focus on. So the biggest issue I see with students, especially in gaming, is that you always think about yourself. So you have a real passion to move into gaming, which is great. And gaming helps you learn broader skill sets to the software world, software design, software programming. But since you have such a passion, you're always thinking about yourself. I want to make this type of game, this because I love playing this. But the problem with that is when you develop yourself and you're ready to go out into the real world and you're trying to get a job, you need to be trained how to work with a team that's trying to solve a larger software challenge that's engineered around business requirements. That's engineered around making profit for your studio or for the company you're working for, meaning other people are going to be buying this software. You're not designing the software for yourself. You need to understand who you're designing for, what problems you're trying to solve for them, even if it's entertainment, even if it's gaming, and how to solve these problems. What type of games does this user like to play? How is the market not fulfilling this user, this player's needs? How can you solve their needs for them? Meaning they would want to buy your software after you make it. So you need to start thinking in these terms as you're developing yourself over your years in college, as you're thinking about which skill sets you want to get really sharp, what portfolio pieces you want to build out for your website, how do you want to refine your resume, and which companies you and job titles you ultimately wish to apply for as you leave college. So you have to start thinking about the user as somebody other than yourself. In this way, in the research phase, we develop what's called personas, these kind of abstracted characteristics of our demographics, so that we can think about this abstracted person, one person, not this massive demographic pool of people, as we're thinking about building the software. And your justification to the persona, because we don't want you just making up random people. And then we have you state what the problem scenario, what type of problem this persona is having that ultimately your software solves. And that's called the activity scenario. So the problem scenario, the activity scenario. And that's the end of it. So we have the problem statement. So this problem statement ends the research phase. So you've stated the problem. Let's get a really good scoping of a solution in sprint 2. So as you see, I'm clicking the buttons on this intro page, and everything moves fine. There's no broken points. It's all been tested. But I can jump home, right? So this is sprint 1. And this is going to be sprint 2. Tutorial and level 1. You could do one of the later on in the class. I'll talk about with the order of building. But notice that there's 3 parts to your prototype, and there's 3 sprints in the class. So you'll build one part for each part of the class. But notice that the intro kind of explains the point of your game, and then the tutorial walks the user through what they need to know to complete level 1. In this case, I'm training my user on how to use the interface. In this case, since it was a VR game, my interface is 3D objects. Your game will most likely not. It's okay to have 2D, like buttons and sliders. Um, in either case, any object that you interact with through your input device can be considered an interface. It's just you're used to these traditional 2D user interfaces, which are like a flat table with some buttons and drop downs and sliders. But the interface can also live inside the game world. So, for example, here, this game world is this table, this sorting tray, and there's buttons on the table that this fake hand. So this virtual hand represents what your hand would do in VR. So anyway, this is the tutorial training them on how to interact with the software, and it's teaching them the basics of bubble sort. This was my learning activity, which is just a sorting algorithm in computer science. And then level 1, it looks a lot like my tutorial. I meant that's okay. I meant the user to be very comfortable moving from the tutorial to level 1, and yours can look the same too. But notice that they're just given a task. My level 1 is, I think, 7 tasks that you must complete to show, and each task gets more challenging to show that you understand the concept. This is called scaffolding. So actually, this is used a lot in video games too. You teach the user or the player some stuff, and then you have them demonstrate it. Okay, now that I showed you how to jump, show me that you can jump. Show me that you can jump over this gap in the level, and on the next side, I'll continue about a new advance. Then maybe a jump and a double jump. If you double tap, and now you have a longer space that you have to jump through. And so this idea of teaching somebody in a video game is very much imbued, even if the game is just a piece of entertainment. But in this case, there's 7 tasks. You must learn how to do a bubble sort on a ever-growing list of elements. And all this is like I spent the whole semester talking about this. I'm really just trying to give you a really strong overview of what to expect in the class. But if you notice here, I think I just have to go through it once more. Okay, so task 1 was completed successfully. Great, let's start task 2. So notice that the list is even longer. All right, so that was my 3 parts of my prototype. Now, that last part, in the tutorial too, has a lot of code. And I actually do explain all the code, and it gets rather complicated. And this is why these classes, these intro classes to game design or educational game design get so overwhelming, is you have to learn all this software design, all this thinking, and then you have to start learning a massive amount of programming. So I will explain all the programming that's happening in mine, and I don't require you as much programming to express your ideas. It's okay if your tutorial in your level 1 is very linear. So it's okay to move through a sequence of animations instead of making it fully interactive to the user. So think of it like a live storyboard or an animated storyboard or a sequence of events more similar to the intro, where if I click play, and the intro is just read this, go next, read this, go next, read this, go next. Now instead of text, be like, well, I think my level 1, I'm going to want the user to learn how to swing a sword, and he has to cut a vine, and then use that vine as a rope to cross the valley. And then I've trained the user on the main parts of my game. On swinging a sword, that certain objects in the environment are interactable and you can pick them up, and certain objects can gain you access to new areas or whatever it is. Or if you're doing an educational game, as objects drop from the top of the world and they fall down, the user can move a bucket left and right. And we're trying to have him only collect spheres. Can he understand the difference between shapes? So there's spheres and cubes and cylinders falling from the ceiling, and the user can move a bucket left and right. And I only want him to collect 3 spheres to pass this level, right? And so I need to train him to understand the difference between shapes. I need to understand him that he can move the bucket left and right. I need him to understand that the winning condition is to get 3 spheres. I need him to understand that if he collects the wrong objects in the bucket, he'll lose a life and he has 3 lives, or maybe there's a way to empty the bucket. But that's you defining the system of your game, the rules for win and loss. But you can imagine that your tutorial in your level 1 would be very similar to my intro, where you're explaining something that, the level would start like this, and I'm going to teach you about the animator and animations, and that maybe an animation plays and shows like an object moving left to right. And then next is, okay, if the user can understand that there's a sphere dropping down, and then you can animate like a sphere moving down. And then next, the user has the ability to move the bucket, and then maybe you show the bucket moving left and right to move underneath the sphere. And then go next, show the sphere going into the bucket, and maybe show like a +1 or something positive that they're getting closer to finishing the task. Like that's going to be what your deliverable is at the end of this class. So it's still going to be an interactive build. It's what we call a WebGL build. It's going to run on the internet. I'm going to train you on all this, how to get it up on a website. It's still going to have 3 parts to it. The intro is focused on your research, and the tutorial focused more on your design, and the level 1 more focused on your implementation. The tutorial and the level 1 are going to be closely related, because you have to train the user on what to expect in level 1, just like you do in a regular video game. And just know that I'm not going to expect a high amount of programming. I teach you all the programming needed to get these UI elements to move back and forth between different Unity scenes. And I teach you how to generate and replace objects. And I'll show you the animation system. Now, as far as content, I don't expect you to make your own content. I'm not going to teach you in graphics. We're going to make use of all the free stuff that's already in Unity. Free meaning already available to you. So all the UI stuff, text, buttons. We have 3D objects like cubes and spheres. Right? Very generic things. And then I'll show you the asset store. Unity's has a very good, let me unclick play. Has a very good asset store, a lot of professionally made wide range of stuff. So it can be 3D models, it can be 2D images, it can be full animation, full animated objects, it can be large pieces of code that give you whole new pieces of features. It can be particle systems. Like here's a fantasy creature pack. So anyhow, I'll teach you how to use the asset store, how to find free stuff, free 2D and 3D objects that you can bring in to your prototype and then move it around, animate it to show what your full game might look like. So that's the essence of the class. And hopefully that all makes sense, and hopefully you can anticipate what this semester will be like. So I will be focusing on teaching what I've learned throughout my PhD, focusing on educational game design. So the idea that educational games are games. Even entertainment games have a lot of learning aspects, so there's a lot of overlap between educational games and games. Just my specialty is educational games, so that's what I'm teaching. And that games are also software. So we need to learn about software design as we do all this, and that this will broaden you out and help your academic and then eventually your industrial careers. Thank you.